Today we'll be hosting a webinar. I'm Ed from Unearthed, and I want to take you through nickel laterite beneficiation challenge. So we're really honored today to have some guests from Vale on the line. We've got Juna and Obez here to answer many of your questions, I'm sure. So there'll be time and opportunity for questions at the end. When we're in the room, if you can just keep your microphone muted, and please feel free to keep your video on. But if you prefer to keep your video off, that's okay. We've got Alex as well monitoring the chat. So Alex is my colleague at Unearthed. She'll be in the chat. Feel free to ask her any particular questions around both the challenge process itself. And also she'll be moderating the question and answers that'll come after this. So thanks everyone for attending. Just a little bit on today's agenda. So we'll be running through the team. So we'll introduce the Vale team who are here to give us a bit of background, both on the opportunity that Vale see in this challenge, but also in some of their challenges and some specific operational challenges that they want to share with you. I'll go through then, they'll hand back to me. I'll go through a little bit on the challenge process itself, how you can engage with us at Unearthed and with Vale, and then we'll dive straight into the Q&A session. So we'll probably be around 15-20 minutes on the upfront presentation, so plenty of opportunity for questions at the end, and please feel free to put any questions in as we go. So without further ado, I'd like to hand over to Juna and Obez if they want to kind of come off chat and maybe just introduce themselves. I know Juna's there in the room, and then we can kind of move into the next part of the presentation.
Okay, thank you, Ed. Can you hear my voice?
Yeah, we sure can.
Okay, let me introduce myself. My name is Rejalina Kanata. People call me Juna. I'm senior geologist in PTVI, Vale Indonesia, what we call. And I'm here with my manager, which is Obez, Bang Obez. Yes.
Hi, everyone. I'm Obez from PTVI, Vale Indonesia. So my background is mining engineer with almost 70 years experience. So nice to meet you all.
Okay, I can continue the presentation. So thank you, Ed, for your time and the opportunity to present. Today we are very excited to share our insight into our current urbanization process. So let me start with the background. Currently, PT Vale Indonesia has operated more than 50 years in Indonesia. As you can see in the picture, our concession mainly focus on the Sulawesi Island and divided into 3 areas in 3 different provinces. And our main facilities in the Sorowako, which is the number 1 in the picture, and 2 areas still in the developing phase, which is Bahodopi and Pomala. Vale play a key role in the world's largest centers of laterite nickel production. We are delivering high-grade nickel grade with the nickel matte with the end of product. And this type of nickel-bearing ore is typically found near Earth surface in tropical regions. And at PTVI Sorowako, we are mining with large excavators that extract the ore from the open pits mining and enabling access to these valuable resources. So this challenge calls on innovators on the worldwide to propose any idea, a physical, chemical, hybrid, even or alternative to enhance our ore beneficiation, sizing, and also dewatering of nickel laterite before entering the smelting stage. Okay, the next slide. So for the overview business process, let's focus on the mining process before feed to dryer. And also, as you can see in the yellow highlight color, because we are focusing in the West Block Sorowako. So let me start with the mining phase. Our nickel laterite ore is extracted from the surface using open cast mining methods. This involves removing overburden, uh, using excavators and also haul trucks. So we are using cut-off grades above 1.5%, and our area divided into two: West Block ore, Sorako, which is our current focus in the study, and also East Block ore or PTVI. Our mining is followed with the good mining practices, including backfilling to restore main area. So as you can see, we have one picture in the left. This is our typical in the Soroko area, which is mixing between soil and rock, what we call in the subplate zone. And the typical moisture for this typical ore is around 34 until 36%. The second process is a screening station. The mine ore is transported to a screening facility where it is physical separated using static and vibrating screen. And there are two main purposes why we are using the screening station. The first one is to remove oversized rocks. As you can see, we can only recover 98% of SSP and 42% of reject. And the second one is to produce more uniform product before going to the wet ore slurper or dryer. However, based on our study, our economic ore is in the fraction below 1 inch. But because this limitation, sticky ore and also fine agglomeration. Because of this, we can only screen maximum in 3 inch. As you can see, product SSP minus 3 inch in the Sorako area. And also the another important is the we add additional 2% of water in the screening station to improve recovery because the ore is very sticky and which possibly hinders the screening process. And with final SSP moisture is around 36 until 38% because we add 2%. As you can see, this is like an example of our screening station product, or what we call SSP, in this minus 3 inch. And the second photo is the 18 reject pile. But as you can see also, there are soft ore material which being carried away with the reject, resulting in suboptimal recovery. The next one is the wet ore stockpile. The screen ore, minus 3 inch ore, is piled in the open areas before feeding into dryer. There are two main purposes why we using wet ore stockpile. The first one, this is act as a buffer between screening and dryer, with the total capacity for Sorako is 900K. And also the second one, we need to allow blending and moisture management. We expected retention time in this wet ore stockpile is from 2 until 4 weeks. And we have the moisture reduction of approximately like 2 until 6%. And expected the moisture before feed to dryer is 30% or below. And the product from the wet ore stockpile is fed into dryer, what we call rotary dryer. And expected product size is minus 1 inch, as I previously mentioned, because our ore, economically ore, based on our study, is below 1 inch. And what we call is the product for dryer is dryer kiln product. After dryer, ore will go to the several process like kiln, furnace, and converter. With the end of the product is our nickel matte, with nickel range from 76 until 80%, with cobalt maximum 1.54 and sulfur maximum 22. As you can see, our recovery is changing from the ROM in West Block 100%, but in the end of product, our DKP only can recover until 29%. Okay, next slide. So based on the explanation, we have 3 current challenges in Sorako ore beneficiation. The first one, outdated physical separation technique. The process relies on the ore screening which possibly no longer sufficient to meet our current goals for now. And the second one is screening limitation, because as already previously mentioned, current our screening station product is limited to -3 inch due to sticky materials. And the second one is the operational inefficiency, because the sticky and agglomerated fines will reduce the screening efficiency. And second one, also the hauling reject +1 from the dryer is not effective. And the second one, the third one is valuables of our reject material is can reducing our evaporator recovery. So this challenge is open for all innovator with propose novel solution. The first one is how we enhance our separation and pre-concentration. So is there any possible new methods to improve our beneficiation before drying and smelting? The second one is we focus on how we reduce our moisture, because that already mentioned, we expect before come to dryer is 30% or below. And third one is enable modular or flexible infrastructure. So design modular, semi-mobile is open also for this one. And the last one is important one, how we can go beyond physical separation. So imagine our ore is the enrichment is below -1 inch, and we open any other methods like physical, chemical, or even hybrid or alternative, or any alternative methods to improve how nickel laterite is beneficiated. So I will back to you, Ed. Thank you.
Thanks, Juno. That's a great overview. And obviously, as you mentioned, there'll be the opportunity for questions after we finish the presentation. Just wanted to introduce Luke Mahoney as well, Chief Technical Officer at PTVI, who's on the call. Luke, did you want to add anything to what Juno had mentioned there?
Yeah, no, hi everyone. So no, I think one, first of all, appreciate the responses. It's quite exciting. And then from my side, as introduced, I'm the chief technical officer, and then for us, when you look at nickel, I think there's an abundance of nickel, and if you're in nickel, you're in Indonesia, and I think that's the opportunity we have when you look at the resource and the resource base and the ability to convert this nickel into a either for a stainless steel one direction, or the alternative is into a class 1 or battery type product. And what we're looking at here is mining costs. Mining's relatively easy in the scheme of things, beside it being very sticky and wet. And so the costs, you got smaller equipment, smaller benches, but it's relatively easy. I think the ability to distinguish ore versus waste, you can do it, but it's still not an exact science when you start to have a look due to the ultramafic weathering part of it. But a lot of the processing, and that's where majority of the costs are. So there's a significant amount of costs in the processing and then further downstream. And for us, especially for this process, it's a pyro process, which needs a lot of high heat, process heat. And so we generally get that from coal or fossil fuels, which from an environmental point of view is something we need to look at. And so where the opportunity is grade is king or queen if we can really nail that one, because we've got the ability to invest to increase the grade, especially closer to the face, to prevent the haulage of waste and prevent the haulage of waste and then losing ore in the screening stations. I think that's the opportunity. But then I suppose the previous thinking's been adding water, which is probably one of the easiest ways to get a level of separation, be it the silica or be it some of the other elements. But when you add water, then you add moisture, and then you add moisture, you need more heat, and then you need more heat, more fossil fuels. And so that's something where here's the opportunity for us to really rethink about the process in terms of how do we mine, how do we selectively mine, how do we separate and dewater if we add water, but there's a lot of moisture. And so I think really appreciate, hence why we threw this out there to I think to see what type of thinking is out there and where some of the, I suppose, innovative technology or just innovative application of existing technology. And I think that's where we're really looking forward to that. So thank you for that. And you got the technical team here to support you with any questions that you have.
Thanks, Luke. Thanks for giving additional context there. And I think it's really important that everyone, here's the bigger picture as well as like looking kind of into the technical detail as well. But I think you'll stay online hopefully, and you can answer any questions that the group has. But yeah, opportunity for everyone, I think, to ask questions next. So I appreciate the input there from Luke. And he did mention the opportunity, and I think the opportunity is broad with this challenge. And PT Vale Indonesia have the clear pathways really to support selected teams. So that may be through bench pilot testing, on-site field trials, potential commercial agreements. But again, it's open and unique to specifically to your solution or the technology that you provide. So there'll be a period of engagement directly with PT Vale specialists really to refine those proposals and define the next steps. So the first step really in the process is to engage through the platform. Tell us all about your solution. Tell us about how it will impact PT Vale's operations. And really want to see you submit and then get that opportunity to engage further and more directly with the technical team. So how do we, well, firstly, what's the timeline? It's probably a good place to start. So we launched at the end of June, 24th, at the end of June, and we currently got submissions open until August the 15th. So you've got kind of 2 weeks remaining. And then there'll be a period of review with the technical team to go into your submission in more detail. We'll probably come back with some questions, and there'll be a period of engagement with you all. And then by the end of September, we'll inform you and let everyone know about the next steps. So how do you submit? Submissions are through the Unearth platform. So there'll be a QR code at the end, and Alex will put in the chat links to how you register. I know a lot of you have already registered on this call, so it's great to see. This is a great opportunity while you're listening to the questions as well. Jump on the website, register. It only takes 2 seconds. Just ask for your name and your email address. There'll be some obviously terms and conditions to kind of read and tick. But yeah, please feel free to jump on the website with the QR code or the link that's coming up. And that's the best way to engage with this process beyond obviously asking your questions today. And then beyond that, the team at Unearthed is here to help. So if you do have any questions or if you've anything that you need after the end of today, please feel free to email myself, Alex, or Jake. Again, Alex will post the email addresses in the chat at the end of this. And really, yeah, we can either pass the questions if you've got technical questions onto the technical team, but we're also here to answer those questions that you might have around the process. And if you're have any issues with submission, please get in touch with us and we can resolve those as soon as possible. So the next step really is to open the questions up to you and see if we can get the technical team to answer them. So I'm just going to go back through here, the questions. So Matthew has asked, could you show a detailed flow sheet? Gina, that might be one for you. Do we have or could share anything detailed in terms of the flow sheet for processing?
Okay, I think it's already explained in the previous slide. So about the flow chart, yeah. So
yeah,
this is like,
oh.
sorry.
Oh, Sorry.
business.
Maybe the question is, Juna, Matthew, flow sheet of the mining, screening, or you're talking more about the process in the rotary kiln electric furnace?
Matt, happy to come off mute if you want to ask your
Right.
question in a little bit more detail.
Yeah, okay,
Yeah,
thanks.
that's good.
Yeah, more about just the material handling side, like where does it end up on a conveyor and yeah, that sort of thing. So that sort of transition from mining to the screening station and where's the conveyors and what's the process look like all the way to after the dryer and the kiln. Yeah.
Okay, we'll see what we have there. I'm thinking a lot of the stuff that we've done has been PowerPoint flow sheets for explanation. I'm not sure of a detailed flow sheet from the screening and that, but Juna and Obus, we can sort of take that back and have a look.
There is, Steve, I think, a good opportunity for you to jump on the site and have a look at the, so once you go through the sign-up process into the actual description of the challenge itself, there's some more information in there. So there are a few kind of, there is a few screening process flow diagrams, both for East type and West type ore. There's a couple of pictures that show really kind of the site specifically, how materials handled. So a great opportunity for you to jump on there and have a look. Next question is from Carolus. Carolus, hopefully I've said your name correctly. What's the capacity of the West area SSP tons per hour? Oh, I think Obez has already answered that one in the chat.
Yeah, I think yeah. So the total SSP production from Sorowako is around 9 million to 10 million per year. So it's divided 12 months. So it's around yes, almost a million per year.
Next question. So we got one from Fernando, directly to you, Luke. What's the importance? What is the importance and relevance of the clay in the overall process, in your opinion?
Great question. I think Fernando, you've probably got a much better explanation about this than me. But I think that the clay is from an absorption of water, and I think the fine particles make it quite difficult from a handling point of view. And when you're really trying to separate the silica, the larger block material, I think it actually adds a complication, but it's the reality of where we are. It's probably a fairly basic response, but I'm not sure if you sort of want to add and maybe a little bit more. Sort of looking at the mineralogy, handability in terms of aspects of the clays.
Mm-hmm. If I may just say this, my only concern on this is how much nickel will be linked to the clay in terms of ultrafine grains and things like that. If this proves to be a major issue, then we run into trouble. If it doesn't, then I'm very confident that we can separate the clay away, and with that, all the other problems attached to it. Thanks, Luke.
Yeah, no, and it's probably a question for us to really understand, I think, the composition of the clays. I don't have that off by hand, but it's probably something worth to have a look at. I'm not sure, Juna, if you've got any more information on that.
Yeah, thank you, Fernando, for your question. Actually, we have some like mineralogical tests. For the clay is mainly in our limonite ore, which is above our saprolite. So the clay is sometimes can be swelling also. That's why we cannot use RC drilling in this laterite or eventually in Sorowako, because the swelling swelling that area. And also the clay is very tricky because it's sticky and a fine grain, and also it can be clog screen and foam agglomerates and also in screening station. So that's why our or in the screening station is -3 inch, because if we go to below there, it can be more difficult to us to screen. But for the, if you detail for the clay, it can be swelling in the some monitor.
Great, thanks, Junior. Thanks, Luke. Vlad has a question. Is the project scope limited to the improvements in the preparation of feed material from ore to the smelter operation? Or would you consider proposals that would convert the ore to Class 1 nickel products directly by a direct chemical process?
I think
I think you've responded a little bit.
yeah, interested. And why I'm saying interested because PTVI, like while we're talking about West Block, East Block, we've probably got the largest. We do have the largest land holding of nickel resources in the world, and so there's opportunities, if not applicable for what we're trying to do here. There's a lot where we're looking at full downstream from resource all the way down to Class 1 and other products. So possibly at the same time, we need to make sure that we get the volume and maintain that. Ideally for Sorowako, we do need to keep production to a nickel matte due to some of our offtakes. And so maybe not completely specific, but yeah, very, very interested to understand if things can be done on scale at a reasonable cost to compete with the other processes to take it from a matte to a sulfate to a Class 1. Yep. Great.
And yeah, Vlad, I think it's a great idea. I've seen in the chat, great idea to just submit some ideas, submit a proposal. Great opportunity to get your solution in front of the PT Vale team. I'd love to see you in the room and connecting with them. So Carolus asked a question: how many tons per month in the West area production? Do we already have that one?
Sorry, what's the question?
How many tons per month in the West area?
If I'm not mistaken, it's like 100 kiloton SSP per month until 600 kilo. Yeah, for especially sorry.
Great. And then Fabio has asked, the cutoff grade is 1.5% nickel. What's the average ROM grade and the grade or enrichment profile from ROM to SSP to DKP? That's something you could share.
So actually, what we measure right now in our operation is only considering a -1 inch in dry basis, right? So, but we already have like a study for particle size distribution. So if we remove +1 from our SSP, from our ore, that can be increase nickel grade significantly. I not remember the number, but we can send the number later on.
Yeah, we can. That's a great great point.
Yes,
as well. So no one.
But just in addition, Ed, so yeah, in our history and experience, that when we try to process the SSP to the dryer, right? So it's like we have a nickel discrepancy. So for the Sorwako itself, reduced by 5%. So why reduced by percent is because of, you know, when we have a drying process, because of the rock size +1 material, then can broke and dilute our ore itself. So that's why there's a dilution factor in drying process. So that's why we have to remove +1 inch before drying.
Great. And so Fabio did a thumbs up for that one, so that's a good answer. But yeah, that's it. Brings a good point. If there are any questions that go unanswered today, we'll endeavour to get you a question from the technical team. So please keep putting questions in the chat, and we'll go through. But we are limited to an hour today. Also, there is, if you sign up for the Unearthed on the Unearthed Solutions platform, you'll find there's a forum as well, so you can have a look at questions that have already been asked by submitters in there, and then responses from the Unearthed team, and we'll endeavour to get you a response from the technical team. But obviously, ask your questions with enough time. If you ask a question close to the deadline, we might not be able to get you an answer. So if you've got any burning questions, please ask them as soon as you can. We've got one from Ilpo, I'm hoping I'm saying your name correctly. How do you do ore grade control? Maybe that's one for Gina.
Yeah. Okay, maybe I can answer. So basically, we are doing with the sampling. We have ore control guy in the every mine phase. So this guy is like control the if this guy is sampling and take the sample, go to the lab, and after that we check the sample if the nickel is above 1.5%, we say it's that ore, and below 1.5 is was the ore burden. So this guy is subjective with differentiate between ore and also waster. So when we start the mining, this guy will communicate with the operator in the excavator. So he will pointing out where's the ore, where's the waster in that area. And also we have like several measurement, like what we call ore exposed measurement, which is the measurement of the ore. So we need to quantify the ore and before we mine it. And also same with in the below profile, what we call in the blue zone profile. So we need to measure that area also. So it's just kind of mixing between the several process, but the sampling is the key for this one.
Great. Thanks, Gina. Alexi has asked quite a few questions here. I'll probably just read out a couple of them. He had to skip to another meeting, so we'll try and answer a couple of his questions, and then you can watch it back later on. So the limonite is particularly sticky and complex to handle, affecting plant availability from equipment and processing point of view. Do you have any mineralogical or chemical analysis by particle size?
Yeah, we have, but maybe we cannot share in this meeting. So after this, maybe in the next process, we can share our particle size distribution just to ensure we are understand with our mineralogy and also the chemistry.
Yeah, that's great. Yeah, I think that's a good point, Junior, as well, that there's obviously this is the first step in the process. So there's an opportunity here for you to share your idea, your solution, your technology, your company with PT Vale, but it's the process, and so there might be some opportunities for you to do like more detailed analysis during that phase. Obviously, whilst we sign NDAs on both sides to make sure that we protecting our information. Next question: do you still operate with silica dioxide? I guess that is a manganese oxide ratio requirement. What is it?
Yeah, we still consider with this one. like bars of nickel above only 1.5%. We still also have limitation in the silica magnesium ratio. So ratio requirement is like 2.1 until 2.4. So it's just like very tricky for in terms of silica magnesia, because in the Soroko also is that kind of different places with the different silica magnesia ratios.
Great. And we'll ask the last one from Alexei, which is it possible to consider alternative mining and ore transportation in conjunction with other drying methods, different to rotary kiln?
I think if any idea positive, it can be, we can do that. So we cannot close our mind with several ideas. So this is just, if this idea is good, yeah, we go with that.
Yeah, great. I think that's the opportunity as well of this process, and this challenge is really to put your alternative ideas in front of PT Vale. Just obviously being mindful of what Luke's mentioned before, in terms of the operational challenges on site, being kind of agile and smaller bits of machinery. So I think there's an opportunity there to see how your solution might fit in with the current operations, and that's something that you can discuss, I think, later on with the team. So Danny's asked, does the reject get crushed and feed back into the process?
No,
Yeah.
actually in Sorwaku, the reject material will be disposed to the waste dump area. It's because of the reject material is the nickel content is very, very low, so we have to remove this one. But
And
for
then
the
Danny's
PTA,
got
yes, but for the
Right.
PTA, yeah, we crush the material to be -1 inch, and yes, mix again with the ore. But for now, our project is focused on Sorwaku area.
Right. And Danny's got a follow-up on fines. So how critical is it to remove the fines? Does it get removed at some point in the process? Do you know any?
I think for critical is to remove fines, which is fines material. The fines material is, as I already mentioned previously, our economic ore is below -1 inch. So the fines is still ore. As you can see also in the reject plus 18 picture, there is still fines ore also in that. So what we need to do is to get the fine ores from the reject. So yeah, there's another process also. So, but I think the remove fines is not, we need to, we don't need to remove that. Yeah, I think, yeah, it's already understood.
Faye asks, is there any expectation to simultaneously sequester CO2 whilst enhancing nickel recovery from laterites? So I think Luke's answered, but any follow-up, do you know?
Yeah, for now, yeah, as I know, sequence is like CCUS is commonly in oil and gas industry, but for our now is maybe we can do, but it's not for now, I think. But we open for any advanced idea for this one.
Yeah.
Yeah, no, and I think that's where I added. It's usually not a main driver, but at the same time, we do have carbon emission goals. We are looking at reducing, obviously, Scope 1, Scope 2, and Scope 3, and so it's favorable if there is a benefit, but not the main driver from, let's say, this specific project, but it is a bonus and keen to understand.
Yeah. Yeah, I think they one thing that we do see, I mean, on Earth run a lot of these challenges globally with lots of different mining companies, is that we see when we have these secondary benefit or kind of adjacent technologies, it's really good to come into the process and see how your technology might also the team can consider your technology alongside some of the more kind of traditional operational improvements, and there may be some adjacent benefit to including that in the process going forwards. So I definitely consider submitting to the challenge. Fernando, do you have any idea of the level of nickel oxidation in the waste piles or tailing deposits? Anything?
I don't think so. One, we don't have tailings. Like all this goes to the RKF, so it becomes a slag. The HPALs are the ones that take the residue and create the tailings. Piles, I'm not sure. I'm not sure, Juna, if we've done any work on the oxidation in the piles.
I don't
You're
have any idea also. Yeah.
Okay.
Yeah.
Alpan asks, can PTVI send some ore samples to a metallurgical laboratory so we can do some tests? Maybe I can answer that one. So there's an opportunity then, obviously, after this process, once you're submitted, for ongoing engagement with PTVI. And so I think it's that would come later on down the process. So definitely submit to the challenge. Let's assess your solution, and then I'm sure the team would be happy to engage in any testing that needs to be done to kind of prove up your solution. Next one is Ilya again. How do you process the tailings? Are you interested in dry stacking? I think we probably just answered that one, but
Yes. Currently, our tailings slag from our furnace, right? So most of the slags are piling in the waste slag pile, right? So, and after that, we use the slag to our existing facility in mining, such as road pavement, etc. So mostly 75% is used to mine.
But if the process does result
That's
in a tailings, of course, we don't. Well, I shouldn't say that. We are starting to look at tailings dams, but the concept would be a filtered stack type tailings.
right. Alex has a few questions here. I'll take them one by one. So there are some ores that are easy to screen, while others are a bit more challenging.
Yeah, we have several kind of ores in here, different geological, and even in Sarawak we have type 1, type 2, and type 3. Goes to type 3 is more easy to screen, more easy to mineable. Go to type 1 is hard to screen and something like that. But yeah, there are several kind of ore, but the typical of ore type 1, even type 2, type 3 is have also specific characterization of nickel, Fa, and also the silica magnesia. So we need to screen all of that ore. However, we have several partners to screen, but we need to screen off the ore. The challenging is always comes, but yeah, we need to fix that with our current screening station. Our current screening station, we have 4, 2 in the west area and 2 in the east area for Sorowako, with a specific type of the screening station.
And can you selectively mine or deliver the less challenging ores to the screening plant?
Maybe in the short term, maybe we can, but in the long term, we need to screen out the ore actually, since all of the mine phase is already planned. So we can selective in the short term basis, but for the long term, we need to screen out the ore. And for the high moisture is maybe related with the vertical characteristic of laterite. Yeah. So when we going to the limonite ore, is maybe we have like more moisture content there because very soft material. But going to the saprolite, going to the below zone is like more dry or something like that. So it's kind of challenging also, but we need to mix all of the process since in the like 1 week we need to mine until 11 until 12 different mine phase. So we need to make sure everything is in the good phase.
Great, thanks. Before I get into the question from Vlad, we're coming up to the end. Probably got about 10 more minutes left for questions. So if you've got a question, pop it in the chat. Then we can get through that today. And also, if you're just listening in the background, another great opportunity to jump on the website on the Another platform and sign up today. There's more information there. There's the forum. You can get more out of that, and then you can also start your submission as well in the background if you're feeling like you've got everything that you need to start that today. So Vlad asks, how can we obtain a small sample of the ore so for laboratory testing? So today obviously we're looking for proposals for your solution, and I think as part of your proposal on the Unearth platform, that'll go directly to the team that you've met today. Make a proposal for what kind of tests you would want to see for your solution, what you would do with that ore, and what kind of tests you would consider, and that'll go obviously into the submission and into the review, and then post the challenge close, the team can kind of engage with you to understand the next steps. Fabio asks, what's the open pit strip ratio?
So it's around 2.5 to 2.7.
Great. And Nicolene couldn't hear too clearly about the information on the slag backfill. So question is 75% of the slag backfilled?
No, 75% is used to mining. 20 up to 25% is backfill in the slag pile.
Great. All right, we don't have any more questions in the chat. So we might, if there's nothing more, give you guys 10 seconds while I move to the final slide. Oh, so Nicolene's asked, so you just mentioned, Obez, that the 75% of the slag was used in mining. Could you elaborate a little bit more on how it's used? Oh,
Yes.
for the road. There you go. Perfect. Oh, and then Satrio asks, could you kindly advise the finest size out of the -1 inch, which can be processed into your dryer?
Yeah, I think it's kind of the particle size distribution. So maybe we can discuss of that after this. So what we can say now is our economic ore is below 1 inch. Yeah.
Okay, great.
And I think the thing we do a lot of dust collection and dust agglomeration, which we do put back into the dryer. So we do have a lot of fine particles that do find its way back through.
Yeah. And Alex asks, So the questions are coming in thick and fast now. I said that you've that we've got 10 minutes remaining. So some nickelite processors are pursuing acid heap leaching. So Brazil and other places. Are you familiar with these projects? Have you ever thought about heap leaching?
Yes, but I think the productivity and the productivity, but also the cost. Like you look at the cost to produce nickel matte, less than $10,000 per ton per nickel. I think those processes you are pushing quite high. Plus I have talked a bit to the Brazilian nickel team. I just think the resonance time and productivity for those as your core process is just inefficient for the volume and scale that we're looking at. But maybe there's some preferable ore that can be done at an okay margin, possibly. But yeah, I think scale is the issue there.
Yeah. But Alex, definitely, if you have a great solution and something that you feel like would be useful for the team to consider, then yeah, definitely pop it in as a submission, and I'm sure it will definitely be reviewed. Ilpo has mentioned about flow sheets, so just want to mention again, on the Unearth platform, there's a ROM to SSP flow sheet, so the kind of screening part of the process. I'll talk to the team about the drying process, and we'll see if we can put something out there if possible. But that'll be on the Unearth platform, and we'll send out a note when that arrives if you're registered. Okay, great. I think we've come to the end. Yeah. So yeah, if you we've kind of come to the end. So any other questions that come through, we'll make sure you get a response from the team. So keep putting them in the chat if you have anything that you want to mention. But now's a great time. Jump on the website and start the submission. As I mentioned in the forum, there's some questions already been asked, and that's the place to really engage. As mentioned before as well, great opportunity if you're having problems with the sign up on the website, or any questions specifically on the process, or any other technical questions, and then you can contact myself, which is ed@unearth.solutions, or Alex at alexandra@unearth.solutions, and we can help you in any way. Please feel free to reach out at any stage. I want to really thank the team. I want to thank Juno, Nobez, and Luke for being here today to answer all the questions, and also I want to thank you all for joining. I think we had almost over 50 in the room at one point. So great to see everyone with keen interest in nickel laterites, which is good to see, and also some great questions that came through, and hopefully you got the answers that you needed. So I think with that, I also like to say thanks to Alex for monitoring the chat in the background for me, and yeah, good luck with the proposal and the submission. And yeah, as mentioned, reach out if you have any issues. But thanks again. See you all soon.
Thanks, Ed. Thanks, everyone.
Thank you all.
Thank you.